This tutorial will take you through the latest features of WaterWorld using the megauser interface. So I've signed into WaterWorld as a megauser and I'm now going to define a run. Let's call it Colombia. I'm going to leave this to 1 kilometer. I'm going to click on define area. So once we've defined our area, we can now go to step 2, which is to prepare the data. So prepare data, and we now see that we have an option here to use alternative input maps. So if I click on that, then the system now gives me the option to change some of the input maps, and the maps that I can change are the ones to do with the climatology. So we can change the temperature and precipitation data, and we can also change the land cover data, and the changes I can make are defined by the system. So for instance, if I look at my land cover data, so we have the cover of herb covered ground. By default, the system will use MODIS 2010 data, but if I click on the options, I can see that I can also use MODIS 2010 data or Landsat 2000 data. And similarly, for precipitation data, we can swap our WorldClim data with trim precipitation, for instance, CHP Clim or BTrim. So we have a couple of alternative data sets for all those variables in the system. Now obviously, for instance, if you want to change your precipitation data from WorldClim to say trim precipitation, it would make sense to do that for all 12 months. But this is a fairly quick way of changing some of the key input data sets, and so you can run WaterWorld without having to upload your own data. You can just use this data that is in the system. So I'm going to close that now and go back. And the other option we have here is define regions of interest, and that is the little gray icon here, and we can also see that at the top window, region of interest. Now if I click on that, we have a new option of defining watersheds of points, and what this allows me to do is to select a number of points on a river network, and the system will then calculate the upstream catchment from that point onwards. So the way to do that is to click on the link. That will give me the map icon here, view in Google Maps. Click on that and that will open up the map with the stream order or river network overlaid on top of it. Now I can now zoom in, and you can see the crosshair here. I need to move the crosshair to a point on the river from where I want to calculate the upstream catchment. So for instance, I can select on this particular stretch of river here, I need to move my crosshair right on top of it. I click on define point, and the system will now tell me that that point is selected. So once we finish that, we can click on go back, or we can just close this window, go back to the ROI form, and then we can calculate watersheds as zones of interest. So let's just call this masks, zone of interest called mask. If I click on submit, the system will now start calculating the upstream catchment from that point, and it tells me that the zone of interest mask has been set. We can have a look at it by clicking on the display GeoBrowse map icon, and you can see that it's a very small catchment that I've defined here at the top, but we can have a look at it in Google Maps as well. And we can zoom in. And so I've only defined one in this case, but the system will allow you to define multiple watersheds this way. And now I can use this watershed to either clip through the data, so my analysis results will only be for this watershed, or I can use it to aggregate my results over. So I'm going to close that now, close this page, close this window, and we can go back to the input data. So that's the two new options in the prepare data window. So now I'm going to just set up the run with my default variables. So I'm going to click on copy directly to your workspace, and that will start copying over all the data I need to do my run. So we finished setting up our data, so I can close this window now and start my baseline simulation. So I go to step 3, start simulation, and I'll leave this to not write monthly maps, and I click on start. And that sets the simulation running. So our baseline has now finished running, so we can close that, and we can now start having a look at some of the policy exercises. So I'm not going to look at the results for now, I'm just going straight to policy exercises, and I'm going to show you some changes to our land use and cover change module. So I'm going to select that, submit, and have a look at the land use change model. So I'll click on the plus. So the new land use change model now allows us to project forward recent rates of deforestation. And so we have a number of different data sets in here: GFC, Forma, Terra-I, or we can do a combination of the. So the GFC data is the Landsat data from Hansen et al. At 500 meter resolution. We have the Forma alerts data sets, which is based on 16 days, which is a series of national and global forests and fire alert data sets. And then we have Terra-I. Forma is only available for humid tropical forest areas, and Terra-I can only use currently for Latin America, or as I said, we can use a combination of these products. Now, to see if there's any deforestation in any of these products, we can click on the compare link here, and that shows us then where there has been recent deforestation. So let's have a look at these maps first before setting up our scenario. So the system will now grab these 3 data sets and give you a comparison. So we now have these data sets ready, so we can either look at the total deforestation over 12-year periods, or we can look at the rate of deforestation as a percentage of land per year. And so we can immediately see that there are quite big differences between these products. So for GFC, for instance, we have a mean deforestation of around 2.9% for this particular tile in Colombia. For Forma, 1.2 on average, and Terra-I gives us the lowest rate of deforestation, 0.84%. But if you look at the spatial patterns, the broad spatial patterns, they are very similar. So we'll get the same thing when we look at the deforestation rates. So this gives you an idea of the deforestation that's happening in your area as an input to the model that we are going to run. So I'm going to close this now, go back to our scenario window, and let's set up this scenario. So we call it deforest, and we can set the change of deforestation. So for instance, let's deforest at 80%. I'm going to set these herb and bear covers to 0 and let the remainder to be assigned by the model. And then we can select any of those. So let's select GFC for 100 years. So we set the recent rate of deforestation as determined by the Hansen GFC dataset for 100 years. We'll multiply the recent rate by 1, so we're just leaving that to the current rate of deforestation. Obviously we can speed this up by setting a higher value than 1 here, but we can also add deforestation. So for instance, if there's no history of deforestation in your study area, you can let the model add deforestation, and it will add it everywhere in your study area where your add rule applies. The other change in this land use change model is now that we can add a management effectiveness index. So that essentially allows you to have deforestation in protected areas or not. So for instance, if I set this to 0.8, then we allow for some deforestation in protected areas. I'm going to set these allocations by agricultural suitability, yes. Plant infrastructure, if that's available, yes. And likely new transport routes, yes. And obviously we can also now target where we want our deforestation to take place. So we can select any of those maps. For instance, we could do something with elevation and say, so this is our elevation map, and we can say, for instance, only target the deforestation where we have an elevation above, say, 1,000 meters, for instance. So that's an option to allocate your deforestation given all those other rules as well. But in this case we are going to leave this to the default, which is to leave the study area mask greater than 0. And then we can define our converted areas and we can turn them into cropping land. So now we've set all the variables for our land use change model. I'm going to click check and submit, and we're going to let that system set up this scenario, and that will take a few minutes. So now the system is done with setting up the scenario, so we can now have a look at the changes under this scenario. So if I click on show baseline and scenario, we can have a look at, because this is deforestation, let's have a look at the change in tree covered ground. So we can see there are quite significant changes here. We go from a mean tree cover of 37% to around 12%, and pretty much a spatial pattern all over the region. So because we converted these deforested areas into croplands, we expect to see, and we can see now there's a big change in cropland areas as well. Now remember, this scenario was for 100 years projected into the future based on current deforestation rates, and you can see there is quite a big impact if current deforestation rates would continue for 100 years. So we expect to see quite a big change in hydrology as well when we run this. So let's run this scenario by clicking on Run Scenario, and that should set the model running straight away. So we don't have to click Start here, it will straight away start running the model. So our scenario is now finished running, so we can close this window and we can start having a look at some of the results by clicking on Step 5 Results Maps, and that should open up the comparison between the baseline and the scenario. So we can now look at some of the changes under this scenario. So the key output map of WaterWorld obviously is the water balance. So let's have a look at the changes in water balance as a result of deforestation. So we can quickly see that we see an increase in water balance in many regions, many areas, obviously because we have less water used by forests, so we have an increase in water balance. We can have a look at the baseline on the left and the scenario on the right. So overall we go from a 2070 over the whole tile to 2090 millimeters a year, and so similarly we expect to see an increase in runoff as well. So let's have a look at the runoff map. If we click on Display in GeoBrowse Map and we change the image, so let's say we set the minimum, leave the maximum to what it was, redraw, and then look at this map in Google Maps, and we can clearly see increases in runoff in rivers here and down here as well. So that's the very quickly the results. So let's go back to the water balance map and open that up. In the GeoBrowse map interface, so we can do the view by functions, change the map, etc. Under define regions of interest, so the ROIs, so that's also this gray icon here. If we now define points on the map, so individually using coordinates, so I click on this and I call this POIs, for instance. I have there a 0.1, I'll leave that, and for instance we want to add another point on the map, and we can do that by clicking on the map. Hang on. And move the crosshair to a point of interest, so say lat here, and longitude, and obviously you can just use predefined points from somewhere else, but this is just as an example, and I copy and paste them, check and submit, close this window, and now go back and view this in Google Maps. Then on all the output maps that we view in Google Maps, we now also see the points that you've identified as points of interest. So if I would open another map, I would also see those points highlighted. So this is very useful if you, for instance, are interested in a set of points that you have previously defined. For every output map that you look at, you will now see where those points are located straight away, and you can zoom in and get the values if you would move your crosshair over there to that point. Obviously you need to zoom in more and query the map at that point, or you can get the stats for all active zones of interest, all active POIs. So in this case it's POI sets. So if I click on stats, then it would give me an Excel file that I can download with the values at those points. I'm going to close that now, and we're going to move to the next thing. I'm going to close this window as well, and I'm going to close this as well. Now another one of the major changes is that we can now also run progressive scenarios. So if I click on the scenario that I'm in, which is the deforestation scenario, I get my scenario view window. So this tells me what the scenario is, what the parameters are that I set for this particular scenario. And at the bottom here we now have an option called progressive scenarios. And so if I click on that, what this allows me to do is to set parameters for progressive scenario that will be realized in 4 steps. So for instance, we've ran the scenario for 100 years. If I want to see what happens in the intermediate period, say 25 years each, I can just leave this to 100, and then the system will automatically run a time step of 25 years, 50 years, 75 years, and 100 years. I can also change other parameter values here. So I could, for instance, change the final value to 100% deforestation, from 80 to 100%, or I could change any of the other things in here. So this allows you to quickly run scenarios again without having to set up the full scenario. So without having to go to step 4, policy exercises, going to land use change model, setting up the whole scenario again, and do that 3 or 4 times over. In this case we can just leave it like this, and then the system will automatically run 4 time steps until it ends up at these values. So if we leave this to default and I click submit, then the system will create 4 separate scenarios, 25 years change each time. So this takes a while to set up, but it's much easier than having to recreate your scenario each time you want to make one change into parameter values. So this works for the land use change scenario as we're doing here, but you can also do that for any other scenario you set up, and particularly useful for more difficult scenarios, climate change scenarios, land use change scenarios, or compound scenarios. So this will take a while, so let's have the system set this up. So the system now tells me that it's done building all 4 intermediate scenarios, progressive scenarios. So I can close this now and I can set it running. Now the other thing to think about with these progressive scenarios is that it builds 4 scenarios plus the ones we already had. So we need to make sure we have enough space before we can set this running. So I'm storing a total of 7 out of 7, so that's fine. And you can see here that these are the 4 scenarios that I've just set up as progressive scenarios. As well, you're not able to build progressive scenarios until you have completed a base scenario. So our deforestation scenario, the one we used to start our progressive scenarios, needs to be finished and run before you can do the progressive scenarios. So that's fine. I can now close this and I can set it to run. So I've now switched on running the progressive scenarios. And so this will take a while because we need to run all the scenarios first. So the scenario that we're running currently is the last one, Deforest Prog 3. We can have a look at all the other scenarios. We go to Manage Simulations and we select our 10-degree tiles. We can see that this is the scenario that's currently running, and we have the other progressive scenarios set up but not run yet, and we will have to set these running manually, so the system can't run one after another. We have to run them individually. So we're currently running the last scenario, but we'll have to set these other scenarios running manually, and we can do that straight from the Manage Simulations window. As you can see, we can set these running from here. So we have now carried out a few of the progressive scenario runs. So there's one more thing that is new to the megauser interface, and that is by going to Manage Simulations and have a look at the simulations. We can now compare alternatives. So I only have 2 of the runs left. I have deleted the other 2 because they still had to be run in order for us to look at outputs. But what we can do is, if I click on Compare Alternatives, this allows me to create comparison maps of all my input data and also output data. So for instance, for these scenarios that we set up, we can have a look at the changes in tree cover, for instance. Now this lists all the maps, so it's sometimes a little bit tricky to find the map that we need. But if we look at cover of tree covered ground, the map that will open is the baseline map. I can close that. I can click on Submit, and then the system will prepare an overview of all the tree cover maps, input maps for the alternatives. That shouldn't take too long. So once that's done, it shows me the cover of tree covered ground, the change in cover, and the percentage change in cover. So if you click on the pluses next to these, you can see the baseline on the left, and then the maps for our alternatives, as well as the changes and finally percentage changes. And we can look at all these individual maps as well by clicking on the green Display and Geo Browse Maps. So we can also do that for output maps. So because I've run all these maps, I have the output maps here as well. So that's the ones that say results. So we can look, for instance, at and compare across all the scenarios all our WaterWorld outputs. So for instance, we can compare the result in one go of the total water balance for those scenarios. So that will give us a similar set of maps as our input, maps so we can compare them in one row. So we have our total water, our change, and our percentage change. And so this gives you a very easy way of quickly comparing the outcomes of multiple scenarios. So that's it for the new features for WaterWorld mega user level. I hope that was useful.